Hello and welcome to the session of Python programming for numerical methods. In this session, we are going to cover numerical integration using trapezoidal rule. Let's look at the procedure of trapezoidal rule for calculating numerical integration. For the understanding purpose, we will take a simple example. We need to evaluate integration of 1 upon 1 plus x square over the limit 0 to 6 using trapezoidal rule. Step 1, either we can assume strip thickness h or number of strips n. Based on that, we come up with h value or n value. This is the formula to calculate integration using trapezoidal rule. So various values of y, that is f of x of I, is calculated in this table. Then we put all the values of y in the given formula of trapezoidal rule and calculate the integration value. The same procedure we are going to follow in the program also. Let's start with the program for the given problem statement. So first thing, I'll write a comment that the program is for numerical integration using trapezoidal rule. After that, we might need to use a function with math library. So let's import math library as m. Now, if you look at the problem statement, the problem is of integration of a function 1 upon 1 plus x square. So let's first create a function by using lambda command. Lambda x, that is function of x, which is 1 upon 1 plus x square. After that, the integration limits x0 is 0 and xn is 6. So this is your input data from the problem statement. First part of the solution, we need to assume either strip thickness h or number of strips n. So let's assume n equal to 6. Then if you look at the formula of trapezoidal rule, a equal to 1 by 2 times h. Okay, so let's calculate h here. H is equal to xn minus x0 whole divided by n. Let's see is our program working or not. So print h should be 1 here. So let's execute this and see h appear in the console, which is 1.0, so 1. So that means this part, up to this part, the program is running good or running fine. Next, let's go for the next term, that is y0 and yn. Okay, so y0 is nothing but function evaluated by putting value of x0, and yn is equal to fun of xn. Okay, so let's again see, check, are we getting the same values y0 and yn? So y0 is 1 and yn is 0.027 So if you look at the table, y01 and yn, that is y6, 0.027. Next, now here we need to calculate various values of y based on various values of x. So y1 to y5 and x1 to x5 we need to calculate. So that is your iterative calculation. So we are going to use for loop. So for I in range 1 to n, because we know that it runs up to n, but this for loop will not execute for n, so it is going to skip the n value. So 6, he will not calculate y6 or x6. So let's check out x of I. X of I will be x0 plus I times h, and based on that value there will be calculation of y value. So y of I equal to 1 of x of I. So here x of y value will be calculated and it will be put into the function to calculate or evaluate corresponding y. Okay, so let's print this and check. So print equal to so let's print this value. By percentage 0.4 f, we are going to limit the decimal to precision of x of I value. Similarly, we'll print y values. Okay, so run. So now see, x1 that is 1, y1 is 0.5, and you can cross check this with the table. All the values are getting correct. Okay, so we reach up to this value is x of I, that is x5. So that means we are getting for each calculation we are getting correct y value. Now the next task, if you look at the formula, the next task is to sum up all these values of y. Okay, so let's do it by applying one trick. So let's declare yi equal to 0, and same variable yi we are going to add it here. So we'll get the total summation. Okay, so that will be this yi will be the total sum of all the values of different y calculated in this loop. Now finally we'll calculate the integration value by using trapezoidal rule. So a equal to 1 by 2 times h times y0 plus yn plus 2 times yi. That's it. This is our solution. Let's print the answer. Print the numerical integration of given problem is Okay, so here we are going to float the answer. So again percentage 0.4f followed by percentage the variable a. Okay, so let's see the final answer. The answer obtained by our program for complete numerical total area is equal to 1.4108, and by our numerical calculation we obtained almost the similar answer 1.4107. Okay, so now, so this was for given problem statement. We can generalize this, we can reduce number of lines and we can generalize this so that there is no need to edit the given program. So even if the problem statement changes, you can execute that by console itself. Okay, so let's generalize this. For that we are going to use def function. So let's take the new script file. Here I'll start with this beginning of the program, and then we are going to use def. The function name I'll keep it as a pra underscore tr parenthesis start. Now here we are going to define various functions. So the function input parameters in our program was fun, x0, xn and n. So let's define it here. Fun comma x0 xn and n. So these are our input parameter indent, and after that I'll just paste this the program remaining part. I'll make sure that the indent is there. Okay, also one can reduce this line. We can evaluate that function here itself. Okay, so this is your generic program or generalized program. So let's execute this. I'll save the file. By pra underscore tr. Okay, first trial run, then we'll call that function by its name pra underscore tr in the console parenthesis start. Now provide the input parameters. So first is a function, so function should be defined with lambda of x and followed by the problem statement problem function x square comma, next is the x0 value, that is 0, then xn value 6 and number of strips 6n, and enter. Okay, so we got this problem. Now we can check for another numerical. So let's try this numerical. The function is under the root sine of x plus cos of x and integrated over the limit 0 to 1, and let's assume 8 number of strips. So this 8 is small n, this under root sine x plus cos x is 1, and 0 x0 and 1 is xn. So I'll call the function. Our program is stored as a pra underscore tr, and the function name is also the same. So first is the function. Function is a function of x, so lambda. lambda x, then the function is square root, so m dot sqrt square root parenthesis, within the square root we have sin x plus cos x, so m sin x plus m dot cos x, sorry, so this is your function, comma, the next value is x0 0, xn 1, and n number of strips 8, then enter. So it will give you the correct answer of numerical integration by trapezoidal rule, that is 1.1385. Okay, so I hope you all understood the part of program. In the next session we'll see one more one more method of numerical integration. So thank you.